Hello everyone and welcome to the week 9 session 1 of automation and robotics. The subject code is 20ME51I. So in the today's session we are discussing more about introduction about simulation software. So here is the table of content now. So introduction to robotic simulation, advantages of simulation software, 5 types of industrial robots and its application, commercial robotics software, introduction to the software called Robotics and importing different robots in this software, and the axis movement of the robot using this software. So introduction to robotic simulation. So the robot designing and testing is a time consuming job. So unlike if you go for a simple machine like lathe machines or CNC machine, so it is possible to produce a prototype because it is in a large quantity. But the robotic design is a very difficult one because to achieve the required workspace, the workspace means the maximum space on which the robot moves. So it is very difficult to design the this workspace. So and its application is also very limited because of its cost. It has a less application. So only the big concerns or the large industries only will go for robots, and it is also time consuming. It requires more time. Unlike the other machines or automobile vehicles, it requires more time. So it has having more joints. So we have to achieve the required workspace. It requires time, and also it is not possible to make prototypes. So the designing requires much time. So these challenges slow down the development of these robots. Because of these challenges, because of its cost and not possible to produce a prototype and costlier and limited application, this becomes its development becomes very slow process. So use of best robotic simulation software somehow reduces these challenges. So because in a robotic simulation software, we can simulate the robot without actually testing in a your production environment. So without testing in a production environment, here only in the software you can design any its movement and you can test. So in the next video we can say the advantages of the simulation software. So simulate in a complex environment. So so actually the application of the robot includes in the industries or in some factories where the environment is like beside the robots we have other work, so we cannot disturb these things. So in a simulation software we can arrange all these environments. So all this environment we can check here. So in the complex environment we can test the robotic movements using simulation software. That's a very advantages of simulation software, and a test in a safe environment. So as I told, in robotic application includes in a production department. So it is not safe to test the robot in the production department because other productions are going on in the beside or in front of that or next to one other production things are going on. We cannot test these things because the persons are moving there. So when you move the robots, it may damage, it may affect, it may cause accidents. So to avoid these things, you can easily check these movements easily in the simulation software. So easy to make changes. So if the possible the movement is not achieved, it is very easy to change the movement in using the simulation software. Similarly, we can save the time and increase the speed of the processor. Save the time means because without developing prototype or designing, we can check the its movement in the simulation software. It usually saves the time, saves the money, because we don't need to produce the prototype or actual design. So you can easily implement machine learning algorithms. So it is related to software thing. So in the next slide, so we'll discuss about 5 types of industrial robots. So the 5 types of industrial robots include Kirsten robot, cylindrical robot, SCARA, 6-axis robot and delta. So here, what is custom robot? So custom robot includes only the linear movement robots. It is only used for picking the component and placing it in a linear movement, in a rectangular, in a straight line. So the custom robots don't rotate. It will not rotate. It won't. It moves only in a linear direction or in a rectangular direction. So its workspace is just like a cube shaped. So its workspace, as I told earlier, the maximum distance or movement that can be achieved using the particular robot. So the movement of the custom robot, since it moves in a linear direction only, it will not rotate. Only it will move forward, upward, downward, and backward movement. So it will move like in a rectangular shape. So its workspace is a cube shaped. So similarly, the next one is cylindrical robots. The cylindrical robots have two movements, that is rotary and linear. So it is a further development of the custom robots. In the custom robot, we have only linear movement. So when a rotary movement is added to this custom robot, it will become cylindrical movements. The workspace of the cylindrical robot is a cylinder. So it is usually used to pick the component, and you can rotate it to 360 degree. The simple application of the cylindrical robot includes picking up, rotating, and placing the work. Pick the component, rotate to 360 degree or required degree, and placing that component. So next one is SCARA. This is very important and very famous one. You can see, you can heard this name everywhere. So these are these robots are equipped with XYZ and rotary motion in one package. So all the package of this custom robots and cylindrical robot is packaged in SCARA robot. The work environment is similar to the workspace, or work environment is similar to the cylindrical, because cylindrical is also the combination of custom and rotary movement. So the SCARA, its movement is also, workspace is also similar to this cylindrical robot. It has, compared to the cylindrical movement, it has a more degree of motion in a radius or arc shaped space. The application of SCARA robots are similar to the cylindrical and custom robot, but SCARA robots can move quicker than these two robots. These earlier robots like custom and cylindrical robot, the SCARA moves in a quicker speed. So next we have 6-axis robot. It is also similar to the SCARA robot. It is also all one in type robot. It has also 6-axis. They are top sized. They are like a smaller one. The 6-axis robots are similar, they are toy size, smaller one. They are typically very large. So it starts from toy sized, and it has a very large also. It is used for large assemblies job, such as putting the seats into seats of the car into a car in the assembly line. You can see in the BMW or any other famous car companies production department, you can see that the seats are placing using robots. So that robots include 6-axis robot. So the Delta, next one is the Delta robot. The Delta robot are fastest and most expensive. So the Delta robot if you compare all these remaining robots, the Delta robot is a costlier and fastest one. They have unique dome-shaped work environments. Dome-shaped. Delta robots have a dome-shaped work environments. Dome means the half of the sphere. Like dome means half of the sphere. So which they can achieve with very high speed. So this dome-shaped work space, they are achieved with a very high speed. The Delta robots are best for fast pickup and place. um, Produce transfer application like moving parts from conveyor belt and placing them boxes or another conveyor belt. The commercial robotic software include RoboDK, ABB, Robo Studio, or Robo Guide. So these are some commercial robotics simulation software which is available in the market. So the some of the basic robotic simulation software for beginners are Microsoft Robotics Developer. robotic virtual worlds. NVIDIA is a platform for robotics. VREP, Gazebo simulator, web robots. So introduction to RoboDK software. So in the next slide means we are discussing more about RoboDK software. Let's directly move to that software. Here, if you install this RoboDK software, it will in the desktop it will appear like this. So, in order to download the RoboDK software, we go to the internet here. Another thing is this RoboDK software is a open source software. We can download anywhere, anytime. It is a free one. So for tutorial one, so if you want higher version means you have to pay that. In that it is possible to transfer the robot program directly to the robot. This is not available. These steps are not available in a open source robot software. So here you go for search here RoboDK software, RoboDK download. You can see here http.robodk.com. So click here. Here you can see the download RoboDK for. You will ask for details, so you can easily download. In the download session, you can easily download for Windows, Apple, everything, other softwares like this. So you can, if you download here, it will be downloaded here. So the size is around 500 MB. So you can install that. One thing is that why we are using this, choose this RoboDK software means it has got 50 brand robots in the its library, and also we will get more than 500 robots type of robot. It is available in the library of the RoboDK software. So it is very easy for the student to learn the movements of the robots using this software, since it is a open source robot. So I have already downloaded this software. Let's click on this RoboDK. So if you initially open the RoboDK software, the initial screen of the RoboDK will be like that. So this is called menu bar here. So this is toolbar. Here, initially if you open this, it will get new station like this. So if you want a particular name, go here, click on new station. If you don't want, delete it directly. So now, so this is called as reference frame. Initially, you will get one reference frame here. So in order to open any robot, you should have to go for here, open robot library. This option is available in the toolbar. Also, it is available in program or file, open robot library here. So if you click on that, you will get, see here, you will get more than 50 brand robots here. So one thing important that in order to access the robot library, you should have internet connection. Without internet connection, you cannot access the RoboDK robot library. So you can see here many brand robots are available here, more than 50 brands. In each brand you have this much of robots here. In ABB's robot, we have 102 types of models. So similarly in Brooks, you have 4 types of models. So more than 50 brand robots are available here. And if you keep on updating the robots, this numbers may increase, because if the company add more robots, it will automatically add to this robot library. So here I'll go for inserting one simple robot here. I'll go for inserting the KUKA. I'll select it is the filter option. Here you can directly select all the robots, the more than 500 robots available here. So it is very difficult to search for my particular robots. So we can filter this robot using this filter option here. I will select the particular brand here. So if you want KUKA robot here, for KUKA robots, in KUKA robot, the more than 117 models are available here. Also, we can select its type. If you want 5 degree of freedom, a 6 degree of freedom, you can check this. This is the filter option. So now it will keep on reducing the models here. So if you filter, it reduces the model here. I'll go for 6 degree. Then reach, you can check here. This reach is the maximum arm movement. So playboard is the weight lift here, weight of the robot, like this, and repeatability. According to a requirement, you can filter the robot and select the particular robot. Suppose I want this robot here. I'll click on open here. Once you click on open, the robot will be downloaded to your initial screen. See here, the robot has come to the earlier we have one reference frame was there. It will automatically come to that reference frame. So if you want another reference frame to insert any object or any tools, you can directly click here. Another frame will come. So if you if you insert any object or any component, it will come with reference to this frame 2. We can rename it using option called right click rename, or also you can click select this particular file name and click on F2 shortcut. So here you can see the F2 shortcut here. So I'll click on this and I'll rename it. I'll rename it as object. Okay. So you can insert any 3D object here for inspection or for any machining, anything with respect to this object. So if you move this object, if you move this frame, automatically whatever the object or any tools containing this reference frame, that will also move. Now I don't want this object, I'll just delete it. Now important thing is the movement. Here you can see the 3 axes here. So every color indicates the different axis here. To see that which color indicates the which axis, you just go for tools option here. You go for display here. Display XYZ letters. Okay. See here XYZ. So here X stands for red color stands for X axis. This blue color stands for Y axis, and similarly this color stands for Y axis. So in order to move this robot, we have many shortcuts. One simple shortcut is just press Alt here. When you press Alt, you can see here an extra movement will come here. So this will indicate press Alt and right click your mouse like this. If you want to move the robot in X, this particular Z direction, you can just click and drag here, but you need to press Alt every time. You can see it is moving now. So if you want to rotate about X axis, you can see this red color rotation arrow. You can rotate here like this. Similarly, if you want to rotate with respect to Y axis, you can rotate like this. Similarly, if you want to rotate about Z axis, we can use this. Similarly, we can rotate here like this. So this is the one kind of movement. So it is manual movement. So if you want to move using a precise value, if you know the precise value, then you just double click on this robot here. This is the robot base axis here. you double click on this, you will get a robot panel here. Here you can get all the parameters here. These are X, Y, Z. So you can see the different distances from with respect to different components here. Here the tool is not attached here. If you attach the tool, the particular tool will appear here. So next is reference frame. This is the reference frame with respect to robot flange. This is the robot flange. So all the distance is mentioned here. This means here x-axis is 0. It is it is matching here. This y-axis is 1000 mm in front of this robot face. So here it is the distance between base of the KUKA. This is the base of the KUKA. With respect to robot flange, this is the robot flange. So here x is it is 0 0 and y-axis is 1000 mm in front of this. Means here to here this distance is here to here. You can see if you want any particular view, you can go for here top view like this. Similarly, front view like this. So this y-axis here 1000 mm from the in front of this. This is the robot base. This y-axis is 1000 mm from the robot flange here. Similarly, the tool frame with respect to reference frame. This is the tool you have not inserted here. If you insert tool, it will come here. So this distance with reference to the reference frame, this reference frame. So if you want to see the robot in a top view, just click on top view here. If you want to see it in front view, just click here. Similarly, right view, left view, the back view. If you don't want any view, if you want isometric view, just click on this tool, isometric view. So it is not available here. If you want isometric view, just you have to directly click on this symbol. If you have moved anything, if you want to fit the robot to a particular screen, click here, it will fit here. Next thing is that rotations. You can see here, this is in translation mode. If you want to rotate here, you have a wheel like this, you can rotate this. You can change the component arms of the robot like this, it will move here. Translation, robot base here. You want a rotation, click on rotation like this, x-axis with respect to y-axis. This is the precise movement. If you know the particular values, you can directly click here. Suppose I want the tool flange 500 mm here. Directly click on this. Here it is varying. This reference frame is varying here. So here, just click on the that values. Just roll the mouse here, like this. It will rotate. If you want rotation here, you see the rotation like this. So this is for automatic movement. So if you want, if you know the precise value, you can directly enter here, like this. So for manual movement, you need to press Alt, like this. You can move. So for precise movement, what you have to do is just click on, double click on this robot like this. You'll get the robot panel where you can move the robot with a precise value, with a known value. If you know the particular value, just you have to enter here. Like this. So this is about the axis movement of the robot. So next commands are like if you want to create a program, you just click on this add program here. So here the program will come. In order to rename this, just click on this, press F2 or right click rename. So you can enter the any program name. I'll press like this. Program will initially it will not contain anything. So in order to create the program, you need to define the movement. So at any position, if in any position you have move the robot in various direction. If you want to come to the home position of the robot, initially when you downloaded the robot, it has got one position. That position is called as home. So if you move a robot by mistakes and you don't know what is to bring back to your home position exactly, just click on the home option here. So the robot will come in a home position. So if you don't want these things, this letters and everything, you can go for tools option. Again, remove this display here. Okay. Similarly, if you want to increase or decrease the arrow size here, you can just press plus minus here, plus option or minus option. Here the arrow size is decreasing and increasing. Sometimes it is very disturbing because if you see the larger arrows here, the entire screen will be covered by this arrow. So if you want to remove the size, just you can press minus or plus. If you press the forward slash, you can see the names of the various components we have inserted. So we have not yet inserted anything. So if you insert the tool, it will show the details of the tools or something, object, everything it will show. So if you want to write a program here, how to do it, I'll explain. So this is the home position of the tool. If you want to insert a particular tool for this, just go to the file, open, go to library here. Here you will find the various programs, everything. Here you just go for paint gun here. Select this paint gun, click on open. The paint gun will be automatically attached to the flange of the your robot. If you now click your robot, double click. Yeah, I already told you I have not inserted any robot. This time I have inserted the paint gun here. So automatically the paint gun will come. So this distance, you can see this is called as TCP here. TCP means tool center point. So this is the tool center point. Okay, so this is TCP here. Now this is your home position. So in order to write the program, what you have to do is just move this robot. Now this initial position I'll give as home position. For that, to write the program, just click on here, add new target. So I'll click on this target, this icon. Here it is also available here in program, add teach target, or also you can press Ctrl T for shortcut. So I'll go for adding new target. So here the target one is added. So if you keep on adding, it will take target 1, target 2, target 3 like that. So this is target 1. I will rename it as home position. Rename. I'll make it as home. Okay. Now I will move this robot either manually or by using these values, parameters. Like this. If you want, you can manually create like this. So this is my second position. Now I'll go, I will add another target here. So this is your target 2. I'll rename it as rename as approach. Okay. Now I got 2 target here. This is your home. If you double click on this position, it will go to the home position. If you click on approach, it will move to the approach position. So home and approach. If you want to program to move this robot from home to approach, you have to give the movement between these two targets. Either you have to go linear movement. You have three options here. This is called as joint movement. This is linear movement, and this is circular movement. So since this movement is not in a linear position, I will give joint movement between this. So for that, I click on home and I'll press control and select the program move. I'll click on joint movement. Similarly, I'll go for approach. I'll click on joint movement. So the joint movement is created between the target, the home position and the approach. So now the program is created. Once you give the movement between any two targets, the two things will automatically comes in the program. That is, one is set reference frame. So I have only one reference frame. This is base reference. If you have another reference, you can add this. You can move that move robot with respect to the particular base frame. To add that, I already told you have to insert this, and you can change here. Change set reference frame. If you have more than one reference frame, it will show here. So with respect to that reference frame, the program will be created. In this condition, in this one situation, I have only one base, so that it will automatically take that reference frame. Next is the set tool. So tool, we have only one tool, that is paint gun. If you have more than one tool, we can select a particular tool. Also, you can change here. Paint gun. If you have more than one tool, it will display here and change the particular tool. So now move J home. J means here joint move. So if you give linear move, it will come like move L. If you give the circular move, it will come like move C. So this is your home position. This is your approach position. So now I'll run the program here. Double click on this move program. See here. If you want to loop continuously, it should follow this path. Just click on this. Click on loop here. See here. You want a fast simulation, you can click on fast and slow simulation. Also, you can set the speed by using right click here, add instruction. Set speed. Speed you can increase or decrease here. Suppose I want 100. Speed I will move here. This is called as station tree. Whatever the action you will do here, it will keep on adding here in the station tree. It is very similar to your model tree in any CAD software. In the right side, left side, to do add on operations like play, round, corner, poles, everything. It will keep on in the model tree. In a similar way, in this robotic software, if you add on increasing your options here, everything will be recorded here, and that this part is called as station tree. So this is about making a simple program here. So these are these three joints. So for for creating any program, you must give any one joint, one of these three joints should have to remember, and you need internet connection. Similarly, you can generate the program for this. To generate that, if you want to, means it is continuously doing work here. So to stop this, right click here, remove the loop here, it will stop. Also, you can press escape, directly it will stop. If you want to generate the program which you want to send to the any robotic software, just right click here and click on generate robot program. Here it is generating a program for this movement. So only some basic movement will be programmed. If you design a complex movement, the program will not be generated because it will ask for a licensed version. Since this is a free version, it will create program for a very small movements and everything. So here is the program has created now. So this is your program. You can see the these are coordinates. So this program is now ready to send for any particular robot which I have downloaded. If you send this program to this particular robot, automatically it will moves. It will be generated program in the actual robot. So that is the advantages of the simulation software. Whatever the movement you want, with considering all the negativity means movement. Next to that, your production things are going on, so that you can limit the movement of the robot, everything here, and you can test here without any prototype. And if you feel safe, then you can directly move to the this program to the robotic software. If you want to change anything, it is very easy to change here. You can change the coordinates here. You can change easily the coordinates, and you can re-enter. It will take. This is it for the today's session. In the next session, we are discussing a simple robot program to generate a rectangular path. So thank you for watching this session.